Are you guys ready for this one?
Alright, we're Team Lorax, and ours is the Tour de Bolts project, and I'm Emily Rose.
I'm Mike Radloff.
I'm Alex Matson.
And Alex George. And our solution to the water pump project was a 30-volt bike generator. The goal of this project was to design and build a bike generator for the water pod. The water pod is a self-sustainable floating community built on top of an old barge. This barge was designed by a group of artists in New York City who will live on it while exhibiting art and sustainable technology for 6 months. The client asked us to build a bike generator to help supplement their energy needs.
So to meet the standards of our clients and to narrow our design, we developed a list of criteria based on their wants and needs, and here they're listed in their order of importance. So first and foremost, we decided adjustability was the top because it needs to be able to be used by children and adults alike for different types of bikes. Durability, it must be able to withstand daily use for at least 6 months, and it has to be up to less than or equal to $300 for our cost. And educational value is also very important. It's basically going to be used mostly for an educational exhibit. Safety is also really important since we do have electrical devices on here, and we may switch that off with near electrical threads. And for efficiency, it has to have at least 12 volts of direct current. And ease of setup, aesthetics, and maintainability are also more important factors to the client and the public. It has to be easy to set up, it has to be presentable to the public, and it has to be able to maintain by someone other than us, the public.
So using that list of criteria, we confirmed our final design, which is shown here, figure 5 and 6. Our final solution is an electricity generating bicycle generator. It met our criteria very closely. And most importantly, it met the criteria of adjustability because they wanted it to be educational for a wide range of people. So this bike generator is able to adapt to children's bikes and both sides of all bikes like shown here. It can be switched out in between bikes in under a minute, just with a few quick adjustments. You can just throw it on there. As you can see here, the trainer stand which we use, this is a bicycle trainer stand where most people would spend their time exercising. What was in the place of the DC motor, which is shown in figure 6, was a resistor, which provided resistance to the person training on it. But now instead it's replaced with a DC generator. So during exercising, the bike creates electricity. The bicycle trainer stand is shown here, the black main thing holding it up, also provided a strong, stable base for the project, which is real important because this will be being used by a lot of people, and a lot of people will be around it having fun with it. So it's safe and strong, and it provided a good place where you can mount everything nice and solid. The DC generator was sourced from an electric scooter. We got it for a really good deal since it's salvage, and it is rated at 36 volts, so you can handle the electricity production that's done on this bike. Shown here, this is figure 7. The old resistors were removed, replaced with the motor. We had a choice of stands to use. We chose this one because the resistor was similarly sized to the motor that was going to be replacing, so we figured it would be a nice, easy change. Additionally, we used recycled aluminum bars to hold the motor up. Shown here in figure 6 again. The aluminum bars hold the motor up in place, and then a pipe clamp holds the motor to those bars. Also shown here, the fuses and one-way diode, which will be shown in the electrical circuit in the next slide.
So here's an AutoCAD drawing of the design, as well as the wiring diagram. We've used a diode to limit current coming back to the generator, and we've got it infused to prevent a current of over 20 amps in case of a short. We're also going to be including a voltage regulator in order to cap the voltage at just above 12 volts. The fuse itself is an automotive inline type with a clear window for easy viewing. So as you can see, the generator is efficient and easy to set up. This solution best meets all the criteria. The generator It produces about 120 watts on average, and it will produce more depending on the cyclist. It's also adjustable and can fit basically any size or type of bike, and the stand is compact and durable. It was also inexpensive to create and can be pretty easily duplicated, and is safe to operate and easy to set up and maintain. Emily?
Right, this project took a lot of time, and this is how it turned out. But we ended up spending an equal amount of time on, generally an equal amount of time on each section of our project, and dedicated about a certain amount of hours to each. But for a total, we had 174 for the entire group.
For this project, cost was just as important as time. Many of the parts we used were donated or salvaged from scrapyards. The motor was salvaged from an old scooter and cost us only $5 for a 36-volt motor, so we were really excited about that. And the aluminum we used to secure it was also salvaged from the scrapyard. What could have been the most expensive part of our project, the bike trainer stand, was donated to us for free. So our total price for this generator was only $17.61 compared to the market price, which was $147.43. Either way, we're well below the $300 price limit for the project, and using recycled materials further contributed to the sustainability of the bike generator and the water pump.
So the maintenance cost on our bicycle generator are actually really low. The main moving part is the roller which the wheel sits on, which moves the DC generator. The moving parts of the DC generator that could come in to need replacing of the brushes that shown here. The brushes in this motor were tested and they're still in good shape, but we're including an extra set for the client's use if the motor starts to decrease in efficiency. Also, fuses. It's really easy to replace fuses in case of a short circuit or overcurrent. So that's also provided a large fuse kit. So overall, it's just really easy to maintain. Not too many moving parts. The ones that are real secure and stable.
This is our lovely Michael Radema riding the Toyota Volt, which you can't see it down here. And so here's our bike trainer, and then it's connected to the motor in the back, which goes to the back wheel, and it's non-mobile.
Yeah, sure. Give a demonstration, but
Exactly.
we have a voltage meter on it right now, sure. You sit on it. You have to use a road bike tire, otherwise it's really hot with a mountain bike type tire. But, so right now it's just pedaling.
Yeah, it's going up. Already right now it's on average of 21.
And then if you're like actually working out, you can start pedaling.
I've got about 30 now.
Yeah, so like the mountain bike tire, it's real loud. You guys have all it's a pretty distinguished sound. It's good to use a road bike or bike with those tires on it.
And we'll put a voltage regulator on too to regulate it for charging the batteries.
So as Team Lorax, we ensure that our Toyota Volt project meets our client criteria and provides sustainable solutions and affordable renewable energy source for the water park project. By being safe and adjustable for different kinds of bikes, we ensure that Toyota Volts will provide an educational experience for children and adults alike. Thank you. Any questions?
Is there any resistance to the DC motor?
Yeah, the brushes and the also motor windings and magnets.
You guys tested on that?
Yeah, we charged a 24-volt battery. But yeah, just the general, just also the frictionless losses from the tire to the roller and from the drivetrain, so there's a lot of frictionless losses.
Do you guys have any idea how inefficient your bike generator is?
It's kind of hard to gauge that because there's so many factors involved in inefficiencies, but just using a DC permanent magnet motor, just heat generated and then also frictionless losses, so that's like a form of relation I was going to do here.
If you have a flat tire, can you still use it?
You have to adjust the tire manually because right now it's gauged to the right place. So
There would be an increase in friction.
Yeah. It's doable though. I think you can just make a titer on it and it would still work.
You need to really charge that
Yeah, we put a 5 foot